So hello everyone, this will be our last lecture for STR. Okay, in the last lecture we completed the Minkowski's space and we discussed some questions, and now in the today's lecture we discuss some more questions from the previous year which are asked in the JEST, TIFR and GATE examination, also in the net. Okay, so let's start. So in the previous lecture I gave you this question, so just correct it. Here answer came to be 9. It will be 8.88 something, so we will write it as 9. Okay, so what was in this question? Like a person on earth observed two rockets A and B directly approach each other with respective frequency, this is speed. A time when the distance between the rockets observed to be this distance, the clocks of the rocket and the earth are synchronized t equal to 0 second. Time of collision in seconds of the two rockets as measured by rocket A frame is x by 10. So we can do it by two ways, by length contraction also and by time dilation. Okay, so both will give us the same answer. So let's just take it according to the time dilation. So this distance is given in Earth's frame. Okay, so now we will the time is given in the frame of A, that is x by 10 between the collision. So according to the Earth, what will be the time? So this is the actual time, so delta t naught equal to this. By time dilation formula we will use delta t equal to delta t naught divided by root 1 minus v square by c square. Here v is the speed of A which is moving with respect to earth. So delta t will be this, x by 10 came upper root 1 minus v is given as 0.8 c, so it will be square will become 0.64 and c square divided by c square, so c square will cancel out and then it will give us 0.36 0.6, so delta t will be x by 6. So this is time measured in earth frame, and this distance is given in earth frame. Okay, so now we can just equate these things. Means means this time is given in this time is for the collision. Okay, and in the earth frame, and distance need to be traveled is this. Okay, so we need a speed, means like let me show you. This A and B are moving like this, A B, this is this side, this is this side. So if this is earth, so according to this need to collide with this, we need to find VA with respect to B. Okay, then it will be in rest. Then the time need to cover this distance between this with this speed will be time equal to distance upon speed, and distance will be t into VAB. Okay, so this time is what? This time is x by 6. This distance is given, which is 4.2 into 10 to the power 8, and VAB we need to calculate. So how we calculate the VAB? The formula for VAB will be VAE minus VBE divided by 1 minus VAE VBE divided by C square. Okay, by that relative formula. And then we will see that one is in plus direction, other is minus direction, so it will come out to a plus, here plus also. So VAB will get this. Now this x by 6 time equal to distance upon speed, that is 1.4, this came to be down 1.48 c, so this is just written as this. Means we write as x by 6 is equal to time equal to distance, that is this, divided by this VAB. Means we just did this formula, means this, we use this time equal to distance upon VAB. Then this type of calculation came out and answer will be 8.88 something, that we can write it as 9. Hope you get it. Second question is, a heavy particle of rest mass m while moving along the plus z direction. Well, let me give you one more thing, that we can solve it by length contraction also. If we see in the A's frame, then A will see this length as contracted, and this length will be contracted as this L naught root 1 minus V A square by C square. So now this length need to be covered, and time is this. So and time equal to distance, that contracted length divided by speed will be VA with respect to b. Okay, so we will get in the last this expression, the same expression we will get, and the answer will be same. So a heavy particle of rest mass m, while moving along the plus z direction, decays into two identically light particles with rest mass m, where capital M is greater than 2m. The maximum value of the momentum that any one of the lighter particle can have in direction perpendicular to the direction is. So we need to find the momentum in the perpendicular direction when this capital M mass decays into two particles. Both particles will be symmetrical, means will divide in symmetry because same mass. Okay, so we define its momentum as p1, p2, p1, p2. Okay, so in the x direction it is moving with p, so 2p2 will be equal to p. Okay, from here we can get the expression for p2 equal to p by 2. Now energy is equal to, if its energy is even, so it also be even, so 2 even will be the energy and initial energy was E. Okay, now we can write this expression E square equal to 4 even square, we square both sides. Then what is E square here? E square is the total energy of this particle. It will be p square c square plus m square c4 equal to, now E1 square equal to uh, E1 square will be p1 plus p2 square c square. No, this is not E1 square. Well, yes, it is E1 square. Yes, here we need to find a write the momentum square of this first particle. So if we its momentum is like this, so it will be root p1 square plus p2 square, and square of will this give us p1 square plus p2 square. So that's why, and then c square and its mass m square c4. This for one particle. We write this from this equation. E1 square will be this and this. Now just rearrange and solve this. In the last we will get, from here p2 will be written as p by 2, p square by 2, and here this term will be cancelled out in the equation when you solve this. In the last we will get p1 square equal to this, and from here p1 will be c by 2 root m square minus 4m square. So this will be the p1 which is in the perpendicular direction. Next question. A rocket is moving in free space with the speed c by 2. After a fuel tank is gently detached, means a fuel tank is getting, sorry, gently detached, the rocket is found to be moving with the speed c by 4 with respect to detached fuel tank. Speed of the rocket in original frame is, so a rocket is moving with the speed c by 2. Okay, and a fuel tank is gently detached. So what do you mean by when something is got detached? Means it will be moving with the same velocity as the rocket in the opposite direction. Okay, so we can write the v speed of tank with respect to rocket as, wait, just a minute. So it's like this. If the tank is detached from it, then it will be moving with c by 2 direction in the same way. Means it is moving, the rocket is moving this, then this is detached, and now they are both moving at the same speed. So fuel tank is moving with c by 2. Okay, now rocket is moving with c by 4 speed with respect to test tank. So the speed of tank with respect to, sorry, the speed of rocket with respect to tank is c by 4. So VR with respect to tank is c by 4, it is given, and V tank is c by 2. Now what we need to find actually, a speed of rocket in original frame. So we need to find the speed of rocket with respect to earth, like that. So VRE will be VRT minus VET divided by 1 minus VRT VET by c square. From here we know the speed of rocket with respect to tank is given by c by 4. And if we talk about tank, then tank is moving with the earth is equal to c by 2. So ET will be minus c by 2. Put it here and just substitute the value, you will get the answer as VR equal to 2 by 3 c. Okay, you can get V equal to minus c by 2. Hope it's clear. So next question you can see here. Let me spell you. A beam of light is propagating through a block of glass with refractive index n. The block is moving with constant speed v in the direction. So this question is already done. You can see in the previous lectures. If you already seen the lectures, then you will know that it's done. A proton from outer space is moving towards Earth with velocity this, as measured in the Earth's frame. A spaceship traveling parallel to the proton measures proton's velocity to be this. Find the speed of spaceship in Earth's frame. So a proton from outer space is moving towards Earth with velocity this. So V proton with respect to Earth is given. Vp is given, that is 0.99 c. A spaceship travel in parallel to proton measures proton's velocity with this. So Vp with respect to rocket is 0.97 c. That is in the parallel. That's why it's positive. Find the speed of the spaceship in Earth frame. So we need to find VRE. So VRE will be VRP minus VEP divided with this. So you can just substitute the values. RP will be minus of this, EP will be minus of this, and just substitute, you will get the answer. Okay, let's move to the next question. A constant force F is applied to a relativistic particle of rest mass m. If particle starts from rest at t equal to 0, its speed after time t is. So a constant force is applied. So we need to find actually the speed after time t if a constant force is acting on a rest mass m. Okay. So we know that equation for force is F equal to dp by dt. It will turn out to be 0 to p dp. Means after time t, it will get the momentum p and time is t. So we can write this equation like this. It will solve to a p equal to ft. We can write the constant also, but at t equal to 0, we will get t equal to 0, p is also 0, so we'll get c equal to 0. That's why we write it like this. Now p will be mv. Here m is relativistic mass and v is the velocity at which it is moving, is equal to ft. So now just rearrange this equation, solve this in the terms of v, means put it here, ft here, then square both sides, then you will get this expression. This is the answer. Next question. A relativistic particle of mass m and charge e is moving in uniform e starting from rest at equal to 0. How much time to reach the speed c by 2? So here you can use the expression we just derived. Means if it is in the electric field, the force will be E, small e, capital E. Okay. So and speed at t equal to starting from t equal to 0, we need to find the time when speed is c by 2. Substitute the values in this formula. V equal to c by 2, F equal to small e, capital E, and then here also in the place of F, then find the time. Find the time. Or you can just do from here also, it will be more easy. Means F will be E, capital E, time you need to find, V is given c by 2, and M is given, that is M also. So you can, from here you can directly find the time. Now next question. Light take approximately 8 minutes from sun to earth. Suppose in the frame of sun an event occurs at t equal to 0 at sun and another event occurs at earth at t equal to 1 minute. The velocity of the inertial frame where events are simultaneous is. So it's like this situation is like this. There is this sun, there is this earth, and at t equal to 0 this event occurs here, and at t equal to 1 minute in the sun's frame, means when clock is at the sun, then it measures that at 1 minute the second event occurred at earth. Okay, so we can see that. So what we are talking about, so event 1 occurred here, second event occurred here with a difference of 1 minute. Okay, t2 minus t1 is 1 minute in the earth, sun's frame. Now the distance between them is L naught, and this distance can be measured as, if time is 8 minutes and c is the speed of light, so L naught will be 8 minutes into c, this distance. Okay, now from the Lorentz transformation equations, we know that if there is some spaceship is moving and it is measuring this time, these two times, the difference between these two times will be this. Just to let me tell you that this is not time dilation. Okay, because time dilation, for time dilation, the s prime frame should be, means the object in the s prime frame should be stationary, mean the difference between x2 minus x1 should be 0. Okay, but here it is not 0, it is actually at the different positions, so that's why you can't take the time dilation. It's just a simple conversion in the Lorentz transformation. T2 prime minus T1 prime will be given by this, and from x2 minus x1 we will write here this L naught, this is the original length. T2 minus T1 will be 1 minute, and put the values and find the value of v, and t2 prime minus t1 prime will be 0 because they are simultaneous. So you can find the v from here. This will be c by 8 it will came out c by 8. So it came out to be positive, then that means the spaceship will be traveling from sun to earth. The next question, let xt, x prime, t prime be the coordinate system used by the observers O and O prime respectively. Observer O prime moves with the velocity v equal to beta c along their common positive x-axis. If x positive equal to x plus ct, x negative equal to x minus ct are the linear combinations of the coordinates, the Lorentz transformation relating O and O prime takes the form. So there was some options there. I didn't write the options, but let me tell you the solution. Means you need to find a relation of x prime positive and x negative prime and x positive prime in terms of x negative and x positive. It's like that in the terms of beta. So how will you do that? So x positive prime can be written as x prime plus ct prime, because the laws of physics will remain same in all the frames. So x positive equal to x plus ct, then x plus prime will be equal to x prime plus ct prime. So we can write it like this, and from the equations given, not given, from the Lorentz transformation equation, we know that x prime equal to x minus vt and t prime equal to t minus v by c square x, and divide by this x minus this. Okay, to get the like this. Now we will rearrange this x plus ct, and then rearrange this also. We get some this kind of expression, and here we will just take this out. We'll get this expression. Now 1 minus v by c and 1 minus v by c, 1 plus v by c, will distribute this and put v equal to beta c. We'll get this type of expression, and this is nothing but x positive. So we'll get this x positive 1 minus beta 1 plus beta. So we get x positive prime equal to, in terms of x plus. Okay, by following the same procedure, x negative prime equal to x negative prime plus ct prime, it will give us this expression. Now there is this last question. A monochromatic wave propagates in a direction making an angle 60 degree with the x-axis in the reference frame of source. The source moves toward the observer with v equal to 4 by 5c along the x-axis. Find the direction of wave as seen by observer in terms of cosine of angle. So situation is like this, that there is this source and light is moving at theta equals 60 degree from the source. Okay, there is this our observer which is attached to the earth. So we can say in the earth frame, the light is moving in this direction. So this will see that this theta is not 60 degree. We need to find what theta will be seen by this man, and what is value in terms of cosine. Okay, so it is given that this source is moving in the x direction with the speed 4 by 5c. So vs with respect to earth is given 4 by 5 c x cap. Okay, now this light speed with respect to sources equal to c cos 60, this will be in this direction, and c sin 60, this will be in the upper direction, y cap. Okay, now okay, we get this. Now the light speed with respect to observer in x direction, speed of this light in x direction with respect to this observer, we need to find that, and that speed will be equal to light speed in x direction with respect to earth, because earth is attached with object of our observer. So vlox will be equal to vlex, and vlex can be find as vls x minus ves 1 minus, this is just we use the relative formula. Okay, so from here we know what is vls, light of speed with in the x direction, that is c cos 60, it will give us c by 2, and v earth with respect to source can we calculate from here, vs equal to this, so ves will be minus 4 by 5c. So substitute here, we will get as vlox equal to this. So speed of light with respect to observer, we found this speed, this. Now if like now see in his frame, now he see in his frame that this c is moving, and he see that this is theta prime, this is moving at theta prime angle according to this observer. So that theta prime will give us in this direction c cos theta prime, c cos theta prime according to this observer. So that c cos theta prime will be equal to this speed what we just calculated. From here we can calculate cos theta prime will be 13 by 14. So we get our answer, theta prime will be cos inverse 13 by 14. So just a point to remember here that c will remain same in all the frame. Means it is moving at c speed. According to him, it is also moving at c speed. But in the x direction, it will be c cos theta prime. And this theta will be vary according to observer. Or this theta will going to vary according to observer or any other observer or any other frame. Only theta will vary. And theta prime, then c cos theta prime will give this speed, which is observed by this observer in this direction. And we calculated this speed from here also. We light with respect to source, with light with respect to this observer, and this came out to be this. So we just equate both the terms and we found the theta prime. So I hope you get the idea. Here our STR ends today. From the next lecture I will start classical mechanics, that will be in separate playlist. Okay, there we will study. Okay, I will tell that in that. So go to check the playlist of classical mechanics. So thank you for hearing this. If you are still having some doubts, you can put in the Telegram channel, or you can just put in the comment section. I will try to help you. Thank you.